Hello students. Our next important polymer is polyacrylonitrile. This is polyacrylonitrile. Okay. For this polymer, monomer is acrylonitrile. Acrylonitrile. Okay. Now what is this acrylonitrile? This is nothing but CH2 double bond CH. CN is there. Okay. Means this is our ethylene CH2 double bond CH2, and from this one of the H is replaced by Cn, cyanide group. One of the H is replaced by cyanide. It is known as acrylonitrile. It is called as acrylonitrile. Okay. Again here it is the polymerization. So when we use peroxide, definitely that is the pre-radical formation. This is the pre-radical initiation, then propagation, and then the termination. This is the mechanism when we use peroxide. Okay. Now what is going to happen? These are the monomers. We have taken n number of monomers. N number of monomers. When they are going to link to each other, this double bond is converted into single bond. Double bond converted into single bond, and to this single bond, to satisfy the valency, one more hydrogen is going to attach over here. Okay, so now this is CH2 single bond CH2. Here it is CH2 double bond CHCN. Here it is CH2 single bond CH2. CN is here, and here it is the link in between monomers. Okay, in between monomers, and this monomer we have shown in bracket, and these bonds to show this monomer is going to link to this monomer at this point. Then again there will be one bond, then again another unit of monomer is going to attach over here like this. So in this way there is a formation of polymer with n number of monomers. Okay, so like this, try to understand in this way. Okay, and they are going to attach to each other n number of times, and that is polyacrylonitrile. Polyacrylonitrile. This is very specific. Why? Because wool substitute, this is used as a wool substitute for making orlon or acrylon. Wool substitute. Okay, this is not cotton or this is not jute substitute. This is not silk substitute. This is wool substitute for making orlon or acrylon. We say like that. Now this is made up of natural wool, or you may say this is a synthetic wool. The synthetic wool is nothing but orlon or acrylon, which is made up from acrylonitrile. Now next is again very important. This is polyamide polymers. Polyamide polymers. Such type of products and such type of linkage we studied in proteins. Okay, this is nylon is also very related to protein structure. How this is so? We will see one by one. This is synthetic linear polymer. Linear polyamide. Okay, generic name is nylon. What is chemical name? This is polyamide, and its generic name is nylon. Okay, these undergo condensation polymerization. Condensation polymerization. Okay, we know there is self condensation always, and one more is there is a ring opening also. We studied this thing in nylon 6, epsilon caprolactam type of formation of polymer. In that we studied ring opening, where epsilon caprolactam is converted into nylon 6. Try to remember this reaction, ring opening, and that also gives us nylon 6. Okay, so when this is a condensation polymerization, then there should be two different units, and one is the dicarboxylic acid, another one is the diamine. This one is the dicarboxylic acid. See, this is one functional group, carboxylic acids. This is another functional group of the carboxylic acids. So these are the two one of the carboxylic acid. So this is di, and its general name is adipic acid. Adipic acid. You have to remember this word, adipic acid. What is this? 4 times CH2 means there is a link in between 4 carbons like this, and there is COH and COH. Okay, so 1 2 3 4 5 6, total carbons are 6. These total carbons are 6, and this structure is known as adipic acid. Adipic acid. Now The another unit is of hexamethylene diamine. This is NH2, this is NH2. So this is known as diamine, hexamethylene diamine. And here it is now link of 6 carbons. So this is, and that group is methylene group, and those are 6 in number. That's why we are calling it hexamethylene. This is hexamethylene. And 2 amino groups. So this is diamine. Okay, what is going to happen? See now here, this adipic acid, dicarboxylic acid, adipic acid is going to react with the diamine, which is nothing but hexamethylene diamine. Okay, they are going to condense with each other. See what is going to happen. See, this is very interesting. Here it is no minus H2O in this step. There is no minus H2O in this step. Next, when they are going to form a polymer, then there is a H2O. Please remember this very well. See, always, otherwise we make a mistake. We are going to do minus H2O here, but this is not the case. Here it is condensation. Condensation. Okay. What happened in condensation here? See, very interesting. Here it is COH and here it is the H2. What is going to happen? This COO is going to remain as it is. These two H and this single H, H plus H2, they form H3 here. They form H3 here. This is very specific reaction. By knowing this, you can remember the preparation of nylon 66. Please focus on this point. Okay. And now here is negative charge, here is positive charge. This is very obvious. Again, one of the H is going to remove from this and it is going to attach to here. So here it is formation of NH3. When it acquires one more hydrogen, so lone pair of electron is used of nitrogen. So here it is positive charge. While is we are removing one proton, then this O is going to acquire a negative charge. So when there is a positive negative charges, then this is called salt. This is called salt. And then next, in the next step, there is removal of H2O. There is removal of H2O, water molecule. Temperature used is 553 Kelvin and very high pressure is required. And then product is formed like this. Here it is from H2 and here it is O is removed. This H2O. See, from here H2 and here it is O removed. H2O. So here is no O now and here is no H2. Only one hydrogen is here. Only one hydrogen is here. We removed two hydrogens from this. Here it is two hydrogens we removed from this. And that's why here it is only one single hydrogen, no oxygen. And now this copolymer is going to link to each other in this way n number of times and there is formation of polymer. Now here it is the amide linkage, C double bond ONH is amide linkage. We studied in proteins and so this is called as polyamide fiber. This is called as polyamide fiber. Okay, now see here 4, 5, 6, from here 6 carbons. Now here are 6 carbons. So the name of this compound is 6,6. Remember this thing, nylon 6,6. In case of nylon 6, there is epsilon caprolactam is ring is opened and converted into only nylon 6. There are 6 carbons. Now here are 6 plus 6, 12 carbons, and that's why 1 6 represents dicarboxylic acid, that is the adipic acid. Another 6 is from hexamethylene diamine, and so the commercial name of this polymer is nylon 66. Nylon 66. Okay, this I explain here again. Number of carbon atoms in the two bifunctional monomers. This 6 indicates. What are the properties? Properties are, this is high molecular mass. We know that now the 6 total 12 carbons and there is a formation of polymer, means it should have a very high molecular mass, near about 12,000 to 50,000 units. This is linear condensation polymer. See, this is a linear condensation polymer. It is going to link here. It is going to link here. So this is a linear condensation polymer. It is having very high tensile strength very high tensile strength. It does not soak in water, we know it very well. Okay, then uses: making of sheets, surgical sutures, bristles for brushes, textile fabrics. Okay, these are the uses of nylon 66. See, when in the examination you have to write very particular use. Don't mix it, don't mix it, please don't mix it. Each and every examiner is having the list of the uses, and if you are going to write randomly whatever is in your mind, you are not going to get marks. Huh? Please be aware of this. Yes. Now next, after nylon 66, next one is a polyester. We very commonly use this word polyester. Ester is nothing but our C double bond O, and here it is R. Any R is the functional group, ester. Okay. Now you can understand what is polyester. This is nothing but ester linkage. You are going to see this ester linkage. Okay. Commercially, this is a very important polyester fiber, and it is called terylene or dacron. We always use word, I want the terylene pant. Okay, so this is nothing but terylene. That cloth is terylene. Okay, so it is, so you are not going to get any creases or something on that. It is very used, it is very easily you can use it. That is the terylene, dacron. Okay, again this is condensation polymerization. You are going to observe condensation polymerization, and here it is, reactants are ethylene glycol. Glycol means there are two OH groups, and another one is terphthalic acid. Again there are the two carboxylic groups attached to the benzene ring, is known as terphthalic acid. Remember the structures in this way. Okay, benzene ring attached to two carboxylic groups, it is known as terphthalic acid. Okay, and this is our ethylene glycol. Ethylene glycol. Okay, so now here see, again here very specific catalyst is going to use. What is that? Zinc acetate antimony trioxide catalyst. Zinc acetate antimony trioxide catalyst, remember, and remember this temperature also, 420 to 460 degrees centigrade. To prepare polyester, which catalyst do you have? You must use zinc acetate antimony trioxide catalyst, and the temperature is 420 to 460 Kelvin. Okay. When you are going to remove the water molecule, when you are going to remove the water molecule from this water molecule you are going to remove, this condensed polymer is formed. This condensed polymer is formed. See now, what is that? Here it is minus H2O. Now from here also one H and this OH is going to remove. So one water molecule from here and one water molecule from this end, these two ends, and there is formation of terylene. See the structure, very important. Okay, you are always going to have questions on this. And what is that here now? One H is removed, so here it is bond CH2 CH2. Then this OH and H remove as a water molecule. So this CH2 directly linked to this oxygen. Here it is the oxygen, and then here it is the OCO. Then this is the benzene ring. Again this OH and H, they are going to form H2O, and that's why here it is again one more bond is formed. And now this is, after the bracket we are writing here N, means this is our polymer, and this polymer is called terylene or dacron. Now what are the properties of terylene? Melting point is 265 degrees centigrade. It is resistant to chemicals and water. We know that few clothing brands doing the advertisement based upon this. Okay, water is not going to absorb, and that is used for the sports clothing. We know it very well. Okay, and resistant to chemicals also. So now what are the uses? This is wrinkle free. This just I told you few brands do the advertisement regarding this. Our clothes are wrinkle free. The wrinkle free fabrics by blending with cotton and terrycot. Okay, now we can blend this terylene with cotton also, and there is formation of terrycot. There is formation of terrycot. When it is blend with wool, then there is formation of terry wool. This is terry wool, this is terrycot. Okay, here again we know the thermoplastic and thermosetting products. PET, always it is written in the capital PET. What is this? Polyethylene terephthalate. Polyethylene terephthalate. This is polyethylene terephthalate, which is used for the making of bottles or packaging containers. That is PET. On so many bottles, this abbreviation is written, so you have to know polyethylene terephthalate it is made up of. Another one is polycarbonates. They are thermosetting, while these are thermoplastic. In the last lecture I explained what is thermoplastic, what is thermosetting, and these are known as high melting resins also. High melting resins, okay, as melting point is 265, so this is also known as high melting resins. Okay, now next is again very important polymer, which is phenol formaldehyde polymer. Phenol formaldehyde polymer. Okay, now this is our phenol and this is our formaldehyde. When they are going to react with each other, such type of polymer is going to form. What is this? This is nothing but thermosetting polymer. Thermoplastic thermosetting polymer. Reaction in between phenol and formaldehyde is going to happen. This is the oldest synthetic polymer. Phenol and formaldehyde, very important. Oldest synthetic polymer. You can Google it and you will come to know when this is formed, when this is prepared. This is insoluble and infusible. Again, very important. High tensile strength. High tensile strength. This is again the very important property of this bakelite. Okay, where we are going to this is the substitute for glass. Very important, substitute for glass. Then this is used in telephone instruments, then kitchenwares. Then this is the very good electric insulator. Good electric insulator. In school days, you know that the one experiment to find out whether it is electric carrier or it is not, and then it shows you it acts as an insulator. Okay, now what is going to happen? See here. Here it is. This is very important preparation of the polymer formation, that is the bakelite. So this is our phenol going to react with the formaldehyde in presence of acid or base catalyst. There are three types of different products we can get. This is the mixture of products. Okay. Now this one type of phenol, this is another type of phenol. Here it is a methyl alcohol group, or you may say methanol group. Here are two methanol groups, while here are three methanol groups, and this is our phenol. Benzene ring with OH is our phenol. Such type of combinations you may get. But from this, to understand our uh, formation of the bakelite, of the preparation of bakelite, first we will see the stage 1, that is the formation of phenol formaldehyde resin. Then in stage 2 there is formation of linear polymer. Okay, this is linear polymer formation. Stage 2, linear polymer formation. Linear polymer formation. This is linear polymer formation. See, it is linear polymer formation. But what is going to happen in stage 3, if you are going to provide heat and specific reaction conditions if you are going to use, then there is cross linked. This is important. First it is linear polymer, which is called as novolac, okay. They may fragmented this question up to this also, how to prepare novolac. Okay, you can have to write up to this, and if they ask you write down the preparation of bakelite or what is the reactions you can write for the preparation of bakelite, then you have to write all these three stages, and in this stage 3 there is a cross linked. Now here it is the cross linked in between this CH2 and these two phenyl groups. In between CH2, in between here there is a CH2 like this. Okay, and now means two linear polymers, they are going to cross link here. These two linear polymers cross link over here. See, both are the same, only there is a cross link in between these two linear polymers is of the CH2. And to understand, I just written in the red pen and in the green pen. These are the two linear polymers. They are cross-linked to each other, and here it is formation of bakelite. Okay. Now, from here onwards, see, few topics are omitted from our syllabus. This is the topic omitted from the syllabus: formation of cross-linked melanine formaldehyde resin. Then formation of Buna S is omitted. Okay. Then molecular mass and degree of polymerization of polymers is omitted. These are the omitted syllabus. This is the formation of viscose rayon is omitted. Okay. Please remember all these things, mark in your textbook. So when you are going to study, you will come to know which is the omitted syllabus. Thank you, students.